In this question, you're being asked to propose a synthesis of the following alcohol molecule, starting with hydrocarbons of 3 carbons or less. So that means the starting material that you can use are hydrocarbons, things that only contain carbon and hydrogen. Every carbon in the final product must come from those permitted starting materials. You can use any other reagents as necessary to synthesize this. Right. So here's the thing about synthesis. There usually is more than one answer, and this is a perfect example of that. There are multiple ways you can do this, right? So I'll try to run through each way that I can think of right now, based on the knowledge that I've given you so far in the book. All right, so here we have a tertiary alcohol, and we know we're allowed to start with hydrocarbons of 3 carbons or less, and we have a lot more carbons than we're permitted to start with, which means we probably use some organometallics, things like Grignard reagents or organolithium reagents. Keep in mind when we use those things, we're typically using them on some sort of electrophile like an aldehyde or a ketone, and the result is usually an alcohol. So as we work our way backwards, we're always going to try to get to an alcohol because that's a moment that we can take this thing apart and figure out the Grignard and the electrophile used to make that specific alcohol. All right. So here we have a tertiary alcohol, and we know that if we take a Grignard and we react it with a ketone, it will always make a tertiary alcohol. So we know we're about to take this thing apart into a Grignard and some sort of ketone. Question is, where are we going to do that? Well, when we look at this carbon oxygen bond, we got to keep in mind at one time, this was the carbon oxygen double bond of our ketone until something came in and reduced it. So either this carbon came in and reduced, or this one did, or this one did. And either way, we can pick any one of those, and it's going to lead us back to our permitted starting materials. So we're going to pick one way so far. We're going to go ahead and say that this here was the new bond. Okay, so I'm going to split it apart right here, which means I'm going to make this carbon the carbonyl, the carbon oxygen double bond, and I'm going to make this carbon the Grignard reagent, the nucleophilic carbon. All right, so I'm going to do this one in the color black here. So we're going to take this apart. Let me actually redraw this alcohol. All right, we're going to take it apart, starting with this bond here. Well, everything on the left side containing the oxygen must have been the ketone. So I'm going to draw a backwards arrow because remember, we're trying to think of how we made this thing. I'm going to draw it very similar to how it is there, but I'm just putting the carbonyl back. And I know that I reacted it with some sort of Grignard reagent that must have been nucleophilic at this carbon here. So it must have been a 3 carbon chain with some sort of halogen. So I'm putting the magnesium there, and then I'm just randomly going to choose chlorine here, but I'm actually thinking ahead. I'm choosing chlorine for a reason. I'm not choosing bromine because I'm kind of keeping in mind that if I do, when I go back and I try to put bromine on this, that bromine is going to end up on this carbon. So I'm thinking ahead a little bit. That's why I'm using chlorine. All right. So let's take this Grignard back and we'll come back to the ketone. And let's just ask ourselves, how do we make this Grignard reagent? Before we do that, don't forget there was an acidic workup step to put that proton on the oxygen. All right, back to the Grignard. So we're just asking ourselves, how can we make this Grignard? Well, we know we always use magnesium metal in some sort of ether solvent. I'm just putting diethyl ether there, and we react that with the corresponding haloalkane. So I'm just putting that chlorine back on that primary carbon there. The next question is, how do I make this 1-chloropropane? How do I make that? Can I make that directly from propane, which is one of our permitted starting materials? Yes, and we can do that. We can use chlorine and UV light to do the radical reaction. And this is why I chose chlorine and not bromine, because if I used bromine here, the bromine would go on this secondary carbon, which means this carbon would have ended up being nucleophilic. And that's not what we want for this particular reaction right here. All right, so here's a permitted starting material. So I'm just going to put a little box around that. Let's go back to this ketone because we have to explain how we made this. So we're just going to ask ourselves, how can we make a ketone? We know we can oxidize a secondary alcohol. The good news about that is that means we must have started with a secondary alcohol, which is good because now, since we're at an alcohol, we have another moment we can take this thing apart. What reagents did we use to make this transformation from the alcohol to the ketone? Could have used the Jones oxidation, could use the PCC method. Both of them would work here. All right, now we're at this alcohol. I'm just going to ask myself, how can I use a Grignard and some sort of electrophile to make this alcohol? Well, it's a secondary alcohol. We know that if we take a Grignard and we react it with an aldehyde, it will always make a secondary alcohol. So however we split this apart, we're going to have some sort of aldehyde there, right? So we either have this as the new bond or this as the new bond, because remember, this carbon oxygen bond was the carbon oxygen double bond of the aldehyde before either this carbon came and reduced it or this carbon came and reduced it. I'm going to go ahead and pick this bond right here as the bond that's being formed here. Okay. All right. Well, if this is the bond being formed here, everything with the oxygen must have been the aldehyde. So I'm going to go ahead and draw that aldehyde in there. Must have been this structure right there. The Grignard I reacted with must be everything down here, which must have been nucleophilic at this carbon here, since that's where the new bond is. So that means the Grignard I used was something like Mg, and now I'm picking bromine. So I'm thinking ahead a little bit here. I want to maximize the amount of this Grignard reagent. So I want to be selective. I'm choosing bromine here. Those two things reacted with each other, followed by an acidic workup to form the final alcohol there, that secondary alcohol. Well, let's just go back to this Grignard reagent. How did we make this? Remember, we always make these from the corresponding haloalkane. So I put the bromine back on. I use magnesium metal, some sort of ether solvent to do that reaction. Now I'm just asking myself, how can I make this 2-bromopropane? Well, can I make it directly from propane? Absolutely. But this time I got to use bromine and UV light to do the radical reaction that will specifically put bromine in this secondary position. I could use chlorine here. The problem is, remember, chlorine is more reactive and it'll end up in the primary position and the secondary position. So that's kind of wasting some of your product there. You want the bromine in the secondary position because that's where you want to make the Grignard nucleophilic. All right, so there's our permitted starting material. All right, let's come back to this aldehyde here. Okay, so how can we make that? Remember, we just have to get this back to a hydrocarbon of 3 carbons or less. I'm just going to ask myself, how can I make an aldehyde? I can make it from an alcohol, the corresponding alcohol, which would be ethanol in this case. Now, what oxidation method do I use here? Do I use PCC? Do I use Jones? Well, remember, Jones will turn a primary alcohol into a carboxylic acid. We have an aldehyde here, so we want to stop at the aldehyde, so we have to use the PCC method here. And now I'm just going to ask myself, how can I make this alcohol? Remembering I got to get back to a hydrocarbon. So how can I make this alcohol? Well, you know a few ways you can make alcohols, but remember we got to get back to a hydrocarbon. So that hydrocarbon must have had a leaving group at some point put on, and then the hydroxide must have came in and kicked it out. So we probably did some sort of SN2 reaction using hydroxide, and you can put a solvent here if you want, but something like acetone, some aprotic solvent. Now, what did the substrate need? It needed a good leaving group. So I'm picking something like chlorine. You could have picked bromine. It's fine. All right, so we have a good leaving group. The hydroxide comes in, kicks out the chlorine, makes the alcohol. Well, how can I make this 1-chloroethane? Can I make it directly from ethane, CH3, CH3? Yeah, of course I can. I can use chlorine and UV light to do that radical reaction. So here's a hydrocarbon of 3 carbons or less. That takes us back to all permitted starting materials. So this would be a good synthesis of this tertiary alcohol here.